what is the available energy. Okay, so if you see, this is a graphical representation of the available energy and the unavailable energy. So this is a statistics. Red lines is a Q supplied, black is a work done, that means useful energy, and this blue color, that means rejected. If you see, this is a graph, okay, which is represent the available, unavailable, and there is a work done. Okay, so see here, the total area covered by this curve or with this cycle is nothing but the this red lines. Okay, so that red lines is nothing but the total energy input, that means Q supplied. Okay, so this is our input. Okay, Q supplied. So then after the, this is a closed cycle. Okay, and this cycle has covered some area we shaded in black lines, so that is a work done. This is our work done. And the blue, that means this, if you see that checkmates, like mates created, square mates created, so this is a rejection of the heat. Okay, so if you see, this is nothing but the our work done, so that work done is called as a available energy. So available energy means the maximum amount of a energy available, or we can say is extract from the supplied heat or supplied amount of a energy. So this is the total energy, this is a total energy. Okay, from T2 to 0. Okay, and S1 to S4, this is the total energy. But from that, how many energy is extract from that input? So only this cycle. So this is our available energy, and this energy is called as a unavailable energy. So this is the available energy, and this area is called as a unavailable energy. So available energy also called as the exergy. So this is a exergy, and this is called energy, that means unavailable energy. So this called as a energy. Okay, so here if you see, this is a total Q supplied. Okay, then this is a work done, and this is a unavailable energy. So this is a available, this is a unavailable. Okay, and this is a total Q supplied. Okay, so this is a shown by the graphical. If you see, what is the that concept. So when a gas is heated at constant pressure, the percentage of energy supplied which goes internal energy of the gas is more for diatomic gas than triatomic gas. Okay, that means at constant pressure the percentage of energy supplied is same. Okay, so the internal energy of the gas is how much? So of course the more in diatomic gas. Diatomic gas means, you know, in our carbon dioxide, or we can say we use the fuel, so that is nothing but the diatomic gas. Okay, so that amount, that internal energy is more than to the triatomic gas. Okay, so here if you see how define the available energy and unavailable energy by the graph, we already studied this, but how to formalize, okay, that available energy and unavailable energy. So don't remember the formula, only going to the concept in our thermal concepts. Okay, so we discuss this is the available energy, this is the unavailable energy. Of course at a high temperature this is the T, and this is the room temperature, or we can say where the gases pass out, that means rejection temperature. Okay, so this is the T naught, we can say sink temperature, this is the heat source temperature, we can say. Okay, so we know that as per our the formula, we know that the Q means, of course, entropy, change in entropy is equal to nothing but the delta Q by T. So delta Q is equal to nothing but the T delta S. Okay, so here available energy also present. So if you if you ask what is the entropy of this system, okay, So this is the delta S, okay, and both are the same, okay. So now we have to find the heat, how many amount of heat is rejected and how many amount of heat is available. So of course we know that the T naught, we know that the S, when they give sink temperature, heat source temperature and the entropies, so that time we can find the heat energy. So how? If you see this is available energy, so how to find the available energy? So of course delta Q minus T naught delta S. So this delta Q is nothing but the what? So it is a, if you see, this is a total amount of a input energy. So that input energy is also called as the delta Q, and minus and subtracted T naught delta S, that means T naught into delta S, that means to find this area, okay. So it's a unavailable energy. So we can say this is the unavailable energy, that means total heat supplied minus this unavailable energy is equal to the available energy. So this is a formula. So of course many times they ask unavailable energy. So of course unavailable energy is nothing but what? Sink temperature into change in entropy, okay, change in entropy. And this is our formula, basically formula efficiency. So efficiency is nothing but the what? And it's valid for the reversible cycle only, okay. This is only a reversible process or cycle, okay. This is the valid for reversible process. If you see this is our basic formula of the efficiency, okay. So how to find the availability? So according to graph we can find this and we put this formula. So okay, so now change in entropy, of course we know that the T naught S2 minus S1, okay, this is already given, okay. And now we have to find this S2 minus S1, okay. So to find that S2 minus S1, important equation for the entropy changing process, okay. So we can use by three formula as per the given data. If they give temperatures and volume, so we use this formula. If the pressure and temperature, then this formula. If volume and pressure, then this formula, okay. So this one. So now how to remember this formula? Very easy, no, don't panic. See here, mCV ln T2 by T1 plus mR ln V2 by 1. If you see here, V2 by V1 is a volume, that means change in specific heat at constant volume. So mCV ln T2 by T1, okay, that means mCV, CV, if you take CV, that means mR ln V2 by V1. If here we use mCP, okay, if the pressure is given, then just only put the here mCP, okay, that like is CP, same ln T2 by T1, only replace P1 by P2, okay, V2 by V1 is replaced again P1 by P2, okay. And when pressure and volume both are given, okay, so that time mCP here also reverse, okay, that means CP at constant pressure. So we can't use the pressure here because pressure is a constant, that means the ratio if you take, so that the ratio P2 minus P2 by P1 is nothing but the what? 1, and the ln1 is nothing but the 0, and hence we take mCP ln V2 by V1, that means there is a value is non-zero, okay. Same here, mCV at constant volume, then we take P2 by P1, okay, we can take P2 by P1, that means mCP ln V2 by V1 plus mCV ln P2 by P. This is the basic formula. And when we find the S2 minus S1, that means delta S by any formula as per our given data, then this value is put in here, okay. T naught also given, sink temperature, and Q supplied is also given, okay. So we can find this available energy. Thank you.